Hello everyone, this is Swati. Today I am going to explain you about the Orange. Orange is a tool for data mining. So let's see briefly about Orange. Orange is an open source machine learning language. It is component based visual programming software for data mining, machine learning and data analysis. Components here in this are called widgets, which range from simple data visualization, subset selection and pre-processing to empirical evaluation of learning algorithms. Data visualization. Visually, program is implemented through an interface in which workflows are created by linking predefined or user-defined widgets, while the advanced users can use Orange as Python library for data manipulation and widget alteration. Graphical user interfaces are built upon the cross-platform. It is packed with the features of data analysis. The features of Orange. Orange is component-based data mining and machine learning software suite. Orange consists of Canvas interface onto which the user places widgets and create data analysis workflow. Widgets offer basic functionalities such as reading the data, showing a data table, selecting features, training predictors, compare learning algorithms, visualizing the data elements. The users can interact by exploring visualization or feed the selected subsets into other widgets. Advantages. It is an open source data mining package built upon Python, C and C++. It works on scripts and with an ETL workflow GUI. Orange is the easiest tool to learn. Orange comes with multiple regressions and classification algorithms. The shortest scripts for doing training, cross-validation, algorithm comparisons and predictions. Disadvantages. It has a limited list of machine learning algorithms. Orange is weak in classical statistics. Like, it can compute the statistical properties but do not provide any widgets for statistical testing. Reporting capabilities are limited to exploiting visual representations of data model. Machine learning is not handled uniformly between the different libraries. Now I am going to explain you about how to download the Orange on your desktop. For downloading the Orange, go to www.orange.biolabs.si. This is the site where you can download the Orange. Go to the official site of the Orange. And now we got a page where we have an option of downloading it. It is also showing the older version of Orange, which is Orange 2.7 is still available for download. But I am going to download the latest version of it, which is Orange 3. Let's click on download Orange. Now we got an options like on which operating system do you want to download. Mine is the Windows operating system. I want to download it on Windows. So download. It is asking me to run or save. I want to save it and run it later. It's a lengthy software and take a bit while to download. In meanwhile, I am going to explain you about some of the features of Orange. Orange is a data mining tool available for different platforms like for Windows, Mac and Linux. Data mining is also a fruitful and funny software. As I already mentioned, that is an open source data visualization and data analysis for novice and expert. It has an interactive workflow with large toolbox. As already mentioned just now, it has an interactive workflow, which is create your own interactive workflows to analyze and visualize your data. It has a data visualization, like Orange is packed with different visualizations from scatter plots, bar charts, trees to dendrograms, networks and heat maps. It also has a large toolbox, over 100 widgets, and it is still growing. It has undergoing the development of some more widgets. We cover most of standard data analysis tasks. Specialized add-ons available like Orange Biometrics. Now my software is completely downloaded. Let's click on run for running it. Yes. It's asking like Orange installer will first launch installation of Python 3.4.3. Orange is in Python script, so it will first install the Python. So let's click on OK. Click on, like, it's asking to select whether to install Python 3.4.3 for all users of this computer. Yes, I want to install it for all users, not just for me. Click on next. Next. Are you sure you want to write? Already I have downloaded Python, so I want to overwrite the existing one. Click on yes and click on next. Click on next. We can see that the Python is installing. Showing that it is successfully installed. Let's click on finish to completely install Python. Now the Orange setup is going to install completely. Now installation is completed. Let's click on close. It is showing that Orange 3 has been successfully installed on your PC. Minimize this. And now I got an icon like the orange canvas. Let's click on this. When we first open the Orange, the first thing we see is the welcome screen, onto which we can start a new data analysis workflow, or open the recent one, or explore the tutorials, etc. Now let's exit the welcome screen. Orange start with a blank canvas. It is a place where all the work takes place by using the computational units called widgets. The computational units of the widgets is a place where the process the data or do clustering and build predictive models. We can find all of them on the left side of the screen, like the file, data and preprocessors, data table, and etc. Usually the Orange data analysis workflow begins with the file, so let's click on the file and it appears on the canvas. And now let's feed the data into the file by double clicking on this. We can browse it, and I am going to use the IRIS dataset. it has now fed the file into it. And now see whether the data has been fed or not. Select the data table widget and draw to see whether the data has been fed. Connect from the left side of the file, like the output of the file to the input of the data table on the left hand side of the data table, and double click on the data table to check the data. And this is all the data that has been fed into the file. It's showing like it has 150 instances, no missing values, 6 features and no missing values. These are all the samples in the file. We have the widgets on the canvas. The widgets communicate with each other, like they have an input channel and an output channel, and both. To feed the data from the file widget to the data table, we need to drag and drop a line from file to the data table. Now let's plot out the data. For plotting the data, I am going to use the scatter plot. So drag a line from the file and select the scatter plot from the widget menu. It's easy when you search the scatter plot for scatter plot. So I got here and double click on the scatter plot to see how it is scattered. And now we got all of the data that is scattered, like the blue indicates setosa, versicolor indicates red, virginica green. We can also change the scattering by selecting different axis on X, like I chosen the sepal length, so we can see the scattering has changed. Now let's get started with data analysis workflow. Creating a data analysis workflow in Orange is simple. So to get started, select the file and load the data into the file. I am loading IRIS data. Now let's check the data in the data table. Connect the file with the data table to check that data. Here is the data of the IRIS. Here we have 150 RS flowers from the species dataset. Flowers are described as the 4 features. They are the length and width of sepal, length and width of flower. Each class is labeled with one of the free classes of species of RS setosa, RS virginica, etc. Now let's visualize the data. Now connect the file to the distribution. By this way, the file widget will select the data that is connected to the distribution widget. In distribution, we can walk through all the features of data like the sepal length, sepal width, petal length and petal width. We can additionally inspect the data in the scatter plot. Like connect the file to the scatter plot. We can change the x-axis and y-axis. The data here is a little messy. Like we have RS versica in green, RS setosa in red and RS virginica in orange. There are some parameters that separate the free classes. I can use a rank projections to separate those. A high score indicates a better separation of different species of RS. The best score scatter plotter with it is with the petal width on x-axis and petal length on y-axis. But there is some overlap of RS versica, versicolor and RS virginica. I will select those data instances in the overlapping region. And now the scatter plot will send the data to the data table. I am connecting the scatter plot with the data table. I see the similar values for all the features like the Versicolor, Virginica, and etc. So I can expand this workflow by adding some more widgets or can save it for the future use. Now I will show you some of the great functionalities of widgets and communication channel. In Orange, there are several ways to add the widgets into the canvas. The first is select any of the widget in the widget menu, like clicking on the file, it will appear on the canvas. You can drag and drop any widget from the widget panel to the canvas, or you can right click on the canvas, there appears a widget menu. On this you can select any of the widget by scrolling down, or can easily search it by typing the widget name in the search box and press enter. Or you can draw a line from output of one widget to connect to another widget, like all the widgets that can be connected to that widget can appear. Can select any one of those and press enter. Orange will not support any of the incompatible widgets. Only the widgets that can be compatible with the one, like the output input to the another one, will only be accepted. So to expand the canvas workspace, go to the view menu and select expand tool dock. I can see that it has been expanded. You can also tell in Orange like what kind of data that you want to send from one widget to another widget. So let's go into briefly by taking some example. Take the file widget and load the file with some of the data. I'm going to use RIS and add a data table and connect the file with the data table, and also take scatter plot. Connect the file with the scatter plot. Also connect the data table to the scatter plot. Now I am going to select some of the instances in the data table. And the selected instances will be highlighted in the scatter plot. We can see the green ones and the red ones here. Those are the Virginica and Versicolor are highlighted. Like this can be used when we want to highlight only some type of important data which is easy for analysis. Now double click on the line between the data table and the scatter plot. Data from the data table is used as a data subset in the scatter plot. We can change it by clicking on it, and now you can draw a new line from other data to the data subset. By this we can say how the communication between the widgets takes place. When we want to remove any of the connections between two widgets, just right click on it. We have an option of removing it. Now I will show you how to load the data in Orange. Orange can read several data formats such as Excel, etc. Preparing the data so that the program can read it is the most important task in data mining. So let's start with an example. Before going into it, the data is a table in which the instances are in rows and attributes are in columns. So now let's create a simple data set. I'm going to create the data set by using the Excel sheet. So we can categorize the people based upon their appearance, like name, gender, height, width, weight and eye color. So let's take that simple data set, like the name, gender, height, weight, and eye color. So let's give some of the instances. Different people have different weights and heights. And people vary different weights based upon their height. And different people can have different eye colors. We can categorize the people based upon eye colors too. So let's save this data. And load the data which we created into the file by double clicking on it. To see the data in the file, let's create a link between file and data table. And we can see that the orange can categorize the data based upon their category. Like the name, it's treated as a string, so we can see it here. We can also change the appearance of the data, like we can place the data columns differently by using the select columns widget. I can drag and drop any one of this in the target variable. You can do apply. And now close it and connect the selected columns to another data table to see the changes. We can see the gender appears before the name. Now the data is correct. Like all the categorical data and the string values are appear as I defined. We can also save data onto the desktop by selecting the save data widget. Double clicking on it, we can save it or save as on the location where do you want. I want to save it on desktop and as people. I already have the name the people, so I'm going to rename it. Now the data is saved. Now I'm going to explain you about the hierarchical clustering. Generally we do the hierarchical clustering on our data sets. So let's use our previous data set, like loading it into the file widget. And connect it with the data table to see the data. But here we have a question like, how do we know there are only the single species of flowers? So now I will show you how to discover groups and possible subgroups and their subgroups. This method is called hierarchical clustering. To see this how the clustering works, we are going to group the flowers together so they go with similar length measurements. the flower with similar measurements will be in the same group. So to see this in more brief, let's connect the file with the distance widget and connect the distance widget with hierarchical clustering. The hierarchical clustering displays a dendrograph, which is a tree that reveals the structure of discovered clusters and the distance between the clusters. So now we are going to annotate the cluster with the species of RS. We can see on the right hand side as the flowers of same species are clustered together, but there is a mix-up area. So to get rid of this problem, we are going to select some particular area of the hierarchical clustering and connect the hierarchical clustering with the data table, and the selected data will appear in the data table. The data that is selected will appear in this data table with the naming as cluster. This is all about the hierarchical clustering. Now I am going to show how to use predictive widget to predict the class labels instances in our dataset. So for this, let's consider the IRIS dataset. In this dataset, we have different features like sepal length, sepal width, petal length and petal width. Based upon these features, we are going to predict like to which RS species the flower actually belongs to. So let's start by loading the data into the file. And connect it to the data table and see the data. Actually, we are interested in what features will classify the species and which tells us the best. We will check this with the classification tree and connect the classification tree with the classification tree viewer. Now we have the different subsets based upon the features and the category to which the flower actually belongs to. In our case, the best feature is the length and width. Here the classification can be done not only by using the classification tree, but also can be done with other classifiers too. The fastest is the regression classifier. Also in regression classifier, the simplest is the logistic regression. We can use those classifiers to predict the species. Hence, this is all about the Orange data mining tool. Hope you all understood well. Thank you for watching the video.